Today we are going to continue on with finding zeros. So last class when we looked at zeros, all of them were ones where you could see where they crossed the x-axis and they all worked out as nice things you could factor as fractions or whole numbers. So today we're going to look at complex zeros. And in a complex zero, that means that we will still have real coefficients, but complex zeros means we're going to have imaginary numbers now, and they also could have radicals as our answer. So in our complex zeros, if a plus bi is a 0, a minus bi is also a 0. So you can't have one without the other one. They always come in pairs. So there's two types of what we call conjugate pairs. The conjugate just means that they have opposite signs. There are real conjugate pairs and complex. Real means you'll just have radicals in your answer. Complex means you'll have an I in your answer. So an example of a real conjugate pair would be something like this. 3 plus radical 3 and 3 minus, whoops, this should be a 3. 3 minus radical 3. So they're exactly the same, just one is positive and one is minus. A complex pair would be something like this. 4 plus 5i and 4 minus 5i. So the reason they all come in pairs is because of the quadratic formula. So if you think about the quadratic formula, which is this right here, the plus and minus in there always means that radical has a pair. So you always have the positive and the negative of it. So whenever we use a quadratic formula, two answers will come out. We will be using the quadratic formula today. If you don't know it, make sure you have it written down and that we can look at it and see what's going on. So we're going to find zeros just like we did before. It's just that sometimes they're going to have radicals like this, and sometimes they're going to have i's. So instead of being able to factor everything, we're going to have to solve with a quadratic formula. So just like we did last class, we're going to start the same way. We're going to find all zeros of our polynomial and write as a product of linear factors. So we have x to the fourth plus 5x squared minus 36. So you're going to start the same thing that we've done every single time. We're going to start by graphing it. So plug it into your calculator and graph it. Notice here is the graph and what it would look like. So I didn't show the bottom part, but that's okay. What we're concerned with is where it crosses. So we can see here that it crosses at -2 and it crosses at 2. So notice up here I have the highest degree of 4, so I'm going to have 4 zeros, but I only see where it crosses the graph twice. That means I definitely will have imaginary ones in my answer. I'll have 2 real ones and 2 imaginary ones. So we're just going to start the exact same way. We're going to work through this with our synthetic division. Sorry, I couldn't think here. So your -2 on the outside. So I'm going to have 1. I don't have an x cubed term, so I have 0, 5, and -36. I'll bring down the 1, work through our synthetic division right here. Oops, I forgot another 0 right here for my x term. I was like, this isn't working, so I need another 0 in here. This would be -18, -18, 36, and 0. So just like last time when we got 2 from the graph, we're going to do it twice. I just did -2, so I'm going to do it again with a 2. Work through our synthetic division. So it'll be 0, 9, 18, and 0. So now we need to put our x's in. So I started with an x to the fourth, so this one would have been x cubed, which means this one down here is x squared. So I would have x squared, I would have 0 x's, and then plus 9 equals 0. So this one we can just solve. So this is x squared equals -9. We have to square root both sides. So this would be x equals, the square root of 9 is 3, and we have to have the plus or minus in front of it. And when the negative, to get rid of the negative, that means I bring an I on the outside because I equals the square root of -1. So the square root of -1 right there means I have an I. So here's my other 2 zeros. So when asked to find all our zeros are -2, 2, and then you can either write 3i and -3i, or you could just write the plus or minus 3i like I did here. When I put these in factors then, that would be x plus 2, x minus 2, x minus 3i, and x plus 3i as my product of linear factors for my answer. So we're adding that I in here this time. All right, let's look at another one. If I want to find all zeros of this one, again, we're going to start the same way we had before. We're going to graph it. I can see in here that I only have 1 0. So I know it's at -2. That means that one of them is real. My i's always have to come in pairs, so my other two are going to be imaginary because it doesn't cross anywhere. So we'll have our -2. Then we have our 1, 0, -2, and 4. Work through synthetic division. So now this would give us x squared minus 2x plus 2. Because I know they're imaginary, I know I can't factor that, and I'm going to have to use the quadratic formula. So remember our quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So our a is 1 right out here in front, our b is -2, and our c is 2. So -b with a -2 makes that a +2. And then in here I would have my b squared, so we would have -2 squared minus 4 times my a times my c, all underneath the square root, all over 2 times my a, which is 1. So now we need to simplify. You need to get inside of the square root what our answer is going to be. So this is going to be 2 plus or minus. If I square my 2, I get 4 minus this. We're all going to have -4 in here, all over 2. So now this is 2 plus or minus. We need to simplify this square root if we can, and we can. The square root of 4 is 2, and the negative means I have an I, all over 2. And then we can simplify this one more time because all these 2's can simplify. So 2 divided by 2 would give me 1, plus or minus 2 divided by 2 here would give me I. So there's my other 2. So my zeros are -2 and 1 plus I and 1 minus I. Or you could just write 1 plus or minus I, that's fine. So there's finding all the zeros. I know it didn't ask me to put this in linear factors, but I'm going to just to show you what it looks like because we will have to. So this would be x plus 2. And then remember, it's always the opposite sign. So the 2 becomes positive. When we do these in here, they all have to change signs also. So it would be x, it was a +1, -1, minus I. Everything has to change signs. And this one would be 1 minus, or x minus 1 plus I. All the signs change on everything. So that would be our linear factors and our zeros. Okay, so there's one. Here's another one. We're going to find all the zeros. Same thing that we've been doing. We're going to start. We're going to factor it. Or we're going to graph it. Sorry, not factor it. So graph it first. We can see that we have a 0 right here at -5. I know I have 3 zeros. So -5 is going to be one of them. My other 2 will have our i's, so we'll start with our -5. Now you're going to have 1, 9, 27, and 35 in here. Work through our synthetic division, just like what we've been doing. So now this is x squared plus 4x plus 7. Again, we know we're not going to be able to factor it because there's nowhere that it crosses the x-axis, so we're going to have our -b, so -4 plus or minus, this would be 4 squared minus 4 times our a is 1 and our c is 7, all over 2 times our a. So -4 plus or minus, we need to figure out what's going to be inside our square root. So inside our square root, we're going to have -12 all over 2. So -4 plus or minus, we need to simplify this square root. So the negative automatically means an I is coming out. The square root of 12, as a reminder, the square root of 12 is the same thing as the square root of 4 times 3. Square root of 4 is 2, and then I still have my radical 3 all over 2. Just like in our last example, we can divide all of these out. So -4 divided by 2 is -2. I'm going to write it down here actually, -2 plus or minus. Here, 2 divided by 2 was 1, so then just I radical 3. So now my zeros over here are x equals -5, -2 plus I rad 3, and -2 minus I rad 3. And then if I want them as linear product of linear factors like it asks up here, this would be x plus 5. And then it would be x, change your signs, remember, so +2 minus I radical 3. and x plus 2 plus I radical 3 for our answers. Okay, so that is, I just want to make sure I didn't have another one. I thought I had one more. I want to go back to, I skipped, if you notice, example 7. So let's go back to do example 7 on here. Again, we're going to start the same way. We have our polynomial. We're going to graph it. So you can see right here, it crosses 3 times. This is not a multiplicity. It looks like it is, but if you zoom in, it's not. I promise normally you will have ones that are very obvious. So this -2 only happens one time, and then there's a 0 here and another 0 over here that we don't know what are. So let's start again, -2. We have our 1, our 4, our 3, and our -2. Work through synthetic division, just like we have been doing. So now again, I have x squared plus 2x minus 1. So we look at it to see, oh, can I factor it? Well, this doesn't factor, so I know I have to use the quadratic formula, which means we'll have radicals. We know that they cross, we can see where they cross, so we know they won't have I in them, but they will have a radical. So if we use our quadratic formula, -b, so -2 plus or minus the square root of b squared, so 2 squared minus 4 times our a, which is 1, and our c, which is -1, all over 2 times 1. Simplify in here, so -2 plus or minus, inside our square root, 2 squared is 4, and then this would be plus 4, so we have 8, all over 2. So -2 plus or minus, if I simplify the square root of 8, that's 4 times 2, so 2 rad 2, all over 2. So again, we can divide those 2's out, so it'd be -1 plus or minus radical 2. So our zeros are -2, -1 plus radical 2, and -1 minus radical 2. In factored form then, that would be x plus 2, and then x plus 1 minus radical 2, and x plus 1 plus radical 2 for our answers. So you're going to have some of these. Some will have radicals, some will have radicals and i's, some might just have i's, or some on your worksheet might look like they did last class also. Remember, when you do your worksheet, you must sketch this graph. If you're getting any answer from the graph, you have to sketch it. Okay, so let's move on. That's all of that type of problem on finding the zeros. The next thing you're going to do is write an equation for a polynomial function with integer coefficients with given the zeros. So here's where they like to try and be a little bit tricky, because you have to remember that i's and radicals come in pairs. So here I know that 4 is 1 and 3i is 1. But the i's, you always have to have 2 of them. So if 3i is a 0, -3i is also. They're just not always going to give that to you, and you have to remember to do it. So then our equation could be something like y equals, and then just put it in our factors. It would be x minus 4, x minus 3i, and x plus 3i. And you're done. You can leave it written like that. You just have to remember to add it if we have pairs or i's or radicals. So example here, I have 2, 4 minus I. I can't just have one I, so I'm also going to have 4 plus I. So then when we write our equation, y equals, this would be x minus 2, x minus 4 plus I, x minus 4 minus I. It tells you to leave it in factored form. We don't want you to multiply it out. Same thing happens on part C when I have a radical. I can't just have one. So if I know minus is a radical, that means 3 plus 2, radical 2, is also 1. So we put them into our factors the same way, write an equation. If you ever see the word write an equation, you need an equal sign. So y equals x minus 2, x minus 3 plus 2, radical 2, and x minus 3 minus 2, radical 2. So in your homework, it will ask you to do that and write a polynomial function. Make sure you have your equals in there just to be on the safe side. And that is the end. Wasn't sure if that was the end or not. That is the end. So your assignment today will be a worksheet. Again, make sure you're sketching the graph when we're doing them. Make sure you're sketching the graph, showing all your work, and writing your answers at the very end. And then you'll have some like this where you are writing your equations. And then there's a couple review ones from last one where you have to list them all using your x equals p over q. So when I get back next class, we will talk about things and I will answer questions. Or you can come in ahead of time during seminar or something and I will help you out. Also, have a great day.